So as we look at our new chapter today, our goal for today is going to be to use angles of a polygon to solve problems. So by way of introduction, what I would like you to do is spend a few moments here, and we're going to do a little exploration. If you recall, about a few months ago, we looked at the sum of the measure of the interior angles of a triangle are, anyone remember? 180. So we had three sides. The number of triangles, there's one triangle, and when you add up all the angles, you get 180 degrees. So what we're going to look for is a pattern. Now, for the next polygons, what I would like to do is you're going to draw just one, you're going to draw diagonals from one vertex. Draw all the diagonals you can from one vertex. Notice here, I have two triangles, one triangle there and one triangle there. So as we start to think about this, I see that I have my original diagram has four sides. After I draw this diagonal, I have two triangles. So what should all the angles add up to? Well, it's going to be 2 times 180, which is going to be 360 degrees. Now, for the next ones, from one vertex, please make all the diagonals that you can, and then count up the triangles. From there, you're going to figure out how many, what they all add up to, and then your goal is, can you generify that? Can you apply that to any polygon, not just, and that's what n-gon means. N-gon means any number of sides. 20-sided figure, an 8-sided figure, etc. All right, so now let's finish up and see what we have here. For this pentagon, I see I can draw two diagrams to make 1, 2, 3 triangles. So a pentagon has 5 sides, makes 3 triangles. So 3 times 180 is going to give me 540 degrees total. Continuing on, for the hexagon, I have 1, 2, 3. So this is going to be a sixagon. A hexagon is going to give me 4 triangles. So 4 times $1.80 is going to be Xbox 720. No, Xbox 360, and then they jump to what? The Xbox One? Right, so what are they going to do? Xbox 2? Then what happens when they get to Xbox 359? They're going to call it the Xbox 360 again? Hashtag forget about it. All right, so this here, there is no n-gon to draw because we actually don't know what it looks like just because n is unknown. So the number of sides an n-gon has is n. So what's the pattern we see here? To get from a triangle, a triangle to the number of triangles is 3 to 1. Quadrilateral to the number of triangles is 4 to 2, 5 to 3, 6 to 4. So that's going to be n minus 2. We're subtracting every time. So how do I get this number from the 4? How do I get this number from the 3? We're multiplying the number of triangles by 180. So what's the question we're asked here is, what is the sum of the measures of a polygon, the interior angles of a polygon? And the answer to that is this. The sum of the measure of the interior angles of a polygon is n minus 2, and n being the number of sides, multiplied by 180. That's it. So if we want to find out how many, what they all add up to, we just subtract 2, multiply by 180. So let's see here, in example number 1, I will do A, then you will do B. We're going to find the measure of the interior angles of the polygon, and let's go ahead and change that. It should actually be the sum of the interior angles of the polygon. Okay, so all we have to do is effectively count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, and I shouldn't mark it like that. It looks congruent, so that's not true. All right, so I see it's 8. It's an eightagon. We call that an octagon. So all I do is say 8 minus 2 times 180. So 6 times 180, but of course we could just plug that into our brain without writing that. That's ugly. So 1080 degrees. 1080 degrees. All right, where we're going to try to find an unknown variable. So what's the missing angle? What's the missing angle? So if you count them up, 1, 2, 3, 4, 5, 6, 7, 8. This too is an octagon. So to find the value of n, what we're going to do is find the sum and set it equal to the sum. And you say to yourself, self? That's stupid. Not unless you find the sum in two different ways. So one of them is just straightforward, right? You just add everything together. The 141 plus the 99 plus the 147 plus the 145 plus the 122 plus the 139 plus the 147 plus... So add all those puppies up. So n plus, I'm going to use my calculator in a second to figure out what that other one is. The sum, the other way to find the sum is just to say 8 minus 2 times the 180. We know theoretically what it should add up to, so practically, when I just go add up the angle measures, I should get it. So I did my calculator, added those up to get 940. That's not a 40, hashtag. Oh man, I just teach math, I don't actually do it. All right, let's change that puppy. 40. Now, when I simplify over on this side, we know that a 6 times 180, was that 1080 earlier? We calculated. N plus 940. So when we subtract, even before, let's pause. Even before, what do we expect our answer to be? What do we expect our answer to be? So now when I subtract it, I get 120. And we practically go back and see. Now again, the diagram might be bad. So even if you got an obtuse when you were expecting acute, you might just go back and check your work. But in this case, the diagram looks fairly corresponding. Good. Check, 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 check. Good. You didn't check your brains out. There you go. 140. I did that on purpose. The next thing we're going to look at is this is a corollary. In other words, it is a sub-theorem of the theorem we just looked at. And this is not talking about the sum of the measures of the interior angles of a polygon. Rather, it's talking about the measure of each interior angle. More specifically, of a regular polygon. In other words, all the angles are going to be the same. So really, all you have to do is this. You take the previous formula, and all you do is divide by the number of sides slash the number of angles you have. And there you go. This will give you one angle measure for a regular polygon. So, here's your best friend, the stop sign. Which, did you know that if there is a white border around it, it just means suggested stop? I'm just kidding about that. No, like, see, this one has a little white border right there, that little white border there. Right. Because some people are gullible. Stop means stop. Hashtag always stop. All right, find the measure of an interior angle. So how do we do that? Just one of these. And a safe assumption over here is that this is regular. A safe assumption is this is regular. Now before we attack, kill, destroy, please tell your neighbor, what does regular mean? All right, so it is true that all these sides are going to be congruent. You do not have to mark them right now. I'm just showing you. And then all the angles also are going to be congruent. So we know that if we're talking about one side, we're talking about all the sides. Talking about one angle, we're talking about all the angles. So this is just a matter of saying 8 minus 2 times the 180, which we already know is 1080, and then we divide by 8. By the way, don't get into the habit of trying to cancel out this 8 with this 8. You can't, because this is being subtracted, not being multiplied. So I can reduce the 8 with the 180 if possible, but don't try to cancel these two out. You would have to cancel out everything, not just the one thing inside there. So when we plug all that into our handy-dandy calculators, I get 1080 over 8 and 135 degrees each. All right, next thing. Now we're going to go backwards because backwards is best. We're going to actually show you the long way to do it and then the short way to do it after we introduce the new dealio. All right, so in example number 4, we're actually given the answer like in Jeopardy, and we're trying to find the question. The measure of each interior angle of a regular polygon is 140. So how many sides does the polygon have? So we're going backwards trying to figure that out. So how would you set this up? Instead of knowing the answer, that is, instead of knowing this 8 and this 8, the question, instead of knowing the 8, we know this number right here. So how do we actually set it up? It's going to look like this. We say, my answer is 144. I don't know how many sides it has. And I don't know how many sides it has here. So we look at this problem, we say, yay for algebra, I'm so excited. Okay, the problem with this is that it's ugly. We can get the answer, and we'll walk through all of it. But in a moment, I'll show you the superest, fastest way to do this, okay? Which is like 1/5 this time it takes you. All right, so let's recall, what do? Whatever I do to one side, I do to the other. So I'm going to multiply both sides by n there. So now I've got 140n equals 180n minus 360. Where did I get that? What did I do? I distributed. So what I did was two things. I moved the n to the other side and distributed while I was at it. Okay, now to get n by itself, I have to subtract the 180 and subtract the 180 and now at this point in time, I'm getting negative numbers, not my favorite, to negative 360. And now divide both sides by negative 40. So the answer here is 9. So what's my answer? 9 sides. It's a nonagon. Yay, us. We found it. So really what we want to do is figure out if there's a faster way. And that's where the next theorem is going to come into play. The next theorem says this. The sum of the measures of the exterior angles of a polygon is what? So let's think about this here. If I take this stop sign right here, and I look at the exterior angles, so here is one exterior angle, and here's another exterior angle, and here's another one there, and another one there, and another one there, etc. So if I keep doing all of those, notice that all of these angles are relatively small. But notice what we're actually doing. If you were to rip these up, rip these up, rip these up, rip these up, what would you notice? It turns out you would go in a full circle. So how many degrees are in a full circle? 360 degrees. There's no formula, it's just a number. The exterior angles of any polygon will always add up to 360. Will always add up to 360. So, in other words, here, this angle right here, plus this angle here, plus this exterior, plus this exterior, plus this exterior, are going to add up to 360. No formula to memorize. All we do is add them up. So to set this one up, I say 52. So 52 plus 76 plus, wait, what's this one? Oh, that one's 90 because it's adjacent to the 90. Then this one over here is also 90. And this exterior angle there is x. And we know they all add up to 360 because we're talking about the outside, the exterior. Ha, hashtag yay. So let me simplify. 8. And then finally we subtract to get 52 degrees. So we just go over here and double check. Does this look acute, close to 45? Oh, that's probably a reasonable answer. Again, you can just plug that in here to check that they add to 360. So is that a little bit faster? Yes, but let's see, how does that apply to this one? How does that apply to this one? Well, it's as simple as this. If we know that the interior angle of this whatever-agon is 140 degrees, what does that make the exterior angle? So it now makes this one 40 degrees. So instead of taking the 140 and playing with that and adding up all these things and dividing it in, all you have to do is say this. I know that all the exterior are going to add to 360, So I'm going to divide it by the one exterior angle, 40. And what do we get?